screen here. Today this session we're going to be going over footprints. I should say footprints part 1 because we're going to take the easy way out and use somebody else's footprints for starters. Eventually we have to teach you how to make your own footprints, and that's going to be a later class. Because you can never be, I think at some point in the future it will be the case that the vendors that will actually supply footprints in all the vendor standard formats so that you basically don't have to struggle to get footprints. But until that glorious day comes, we're going to have to sort of work around the issue. Oh, might want to pick up that sheet of paper on the table. So, today we're going to be starting off with this little cheat sheet which says IPC 7351B, naming conventions for standard SMT LAN patterns. I have a link to this document somewhere. I think I've uploaded it to the project, the class homepage. If not, it'll show up later today. So IPC, I'm not really sure what IPC stands for, but International Printed Circuit Consortium, whatever. Okay. 7351, well, you got it. It's a number. B, this is revision B of the spec. Basically, they noticed that everybody was using different naming conventions in their tools, and there was no consistency on everything. So they said, let's come up with some naming conventions. So if you look down this thing, you'll see, wow, there's a lot of possibilities here. So you have ball grid arrays, capacitors, diodes, inductors, LEDs, the resistors, quad flat packs. You get the idea. Okay. And then this basically tells you how to decode this stuff. Oh no, there's nothing to write with. I didn't think about that. Oh well. I'm going to talk through it for the moment. You found one? Yeah, the whiteboard's clearly over there next to the little mill. So basically the way this stuff works is I've got some sort of, prefix. I'm going to do quad flat pack. So this will be we'll do QFN. QFN. That stands for quad flat pack with no leads. And then the next number is the pitch of the leads. Okay. And so if your pitch on your leads is 0.5 millimeter, that translates into 50. And you've got the letter P, and then you have body width and body length. Okay, and that will again be in, I think that's hundredths of a millimeter, don't quote me. It would make sense if it was hundredths of a millimeter. I'm tired of making assertions and being proven wrong. So you might have a 1400 by 1400 package. That's the outer dimensions of the package, so this is a square one. And let's see. And then you have height. Now, height is not technically needed for the printed circuit board part of this stuff. But if you need to do pick and place at a later date, the pick and place machine needs to know how high everything is. So you put a height on here. So I'm making this up. I'm going to say this is 8. Okay, then comes the number of pins, and that's fairly easy. It's the number of pins, and they will add 1 on that if it's got a thermal footprint underneath the package. Okay, so if you see 81, it means that there's 80 pins plus 1 thermal footprint underneath the package to do it. So that's why you sometimes get odd numbers of pins. And then there's a letter. And the letter is either N, M, or L. L means it's got the least area of stuff underneath the pads. And that's what they use for cell phones, because they are absolutely fighting for square millimeters of space on a cell phone. So they use the absolute smallest footprints. M is what they use for aerospace. This is where they want as much reliability as they can get. So they want as much footprint area underneath the lid so they get really nice solder fillets that cover the pads. And then N is nominal, and that's what the rest of us use, which is this fairly standard, not too big, not too small kind of thing. So that's what a footprint looks like. Okay. So this is kind of something we'll do, something that size. So now the question is, how do you get your hands on these things? Okay. And the answer is it's not all that easy. The way I got my hands on them is there's a printed circuit board system that works on Windows called Free PCB. And that gentleman basically got his hands on a free program that was distributed by, I think it was called PCB Matrix, but don't quote me on that name. And he basically generated close to 2,000 footprints. Okay, he generated a lot of resistors, capacitors, quad flat packs, all of that stuff. And he ships them with free PCB. And I'm going like, oh, free PCB, you know, it's probably a very good little program, but I'm kind of a Linux snob, and I wanted to run KiCad because KiCad runs on Linux. Free PCB, does, to the best of my knowledge, does not. So I grabbed those files and converted them to KiCad using a converter program. Okay. So this has all been pushed up onto one of my GitHub repositories, and if I haven't pushed the link to that, okay, I will later today, and you should be able to find it. So the basic concept is you're going to need to be able to access a file for KiCad called IPC 7351-nominal.mod. Mod is KiCad speak for footprint. Okay, that's what everybody calls them, except the standards committee who calls them land patterns. Okay, so that's kind of the short and sweet on these things. And what will happen is you'll get a lot of your footprints out of this library, and then you'll run into an occasional one that isn't in here, and that's when we're going to have to teach you how to use the footprint editor inside KiCad. Pushing that off for another week or two. So we really want to stay with these footprints. Okay. In addition, KiCad comes with a bunch of footprints itself. Completely random. Well, could somebody hit the shift key on my laptop there? Wake up. Thank you. I find that they seem to be completely random, but more critically, you're not really sure when you get one of those footprints whether or not it will actually fit the part that says it fits. Okay, so I thought the thing called SOT23, which is a very common small outline transistor package, SOT. I thought it would work fine. I used it, and it turned out the leads were in the wrong places. So that's a cautionary tale. Anytime you grab a footprint you probably want to do at least some eyeballing of it to make sure that it looks like it's going to actually work. Because otherwise, you've got to do another, you either got to hack around it or you've got to do another rev on your printed circuit board to deal with the fact that your footprint leads are not correct. And that's the final thing I don't want, let's say final, but when it comes to footprints, almost everybody keeps track of their own library that has their own good stuff that they know works. Okay, everybody for all packages across the industry seems to do that. There may be people who are sufficiently happy with the quality of control with some of the high-end ones like Altium that they don't keep their own track of their own libraries. But basically, you need to be very worried about it. A guy that did a lot of this work, his name's Tom, and I can't remember pronounce his last name. It's some German thing like Hasher or something like that. Please forgive me for mispronouncing his name. He's done a lot of work promoting this standard, and I will have a couple of pointers to documents that sort of talk more about footprint standards and the like. I think he's restarted his, I think he did PCB Matrix, and I think he's now doing PCB libraries. So, anyhow, footprints are really critical because if you don't have them, you won't be able to lay out your board with surface mount. Now, if you're doing through-hole stuff, that tends to be a little more forgiving. First, the tolerances aren't as tight. And second, they're all pretty much, a hole with, either a round or a square pad around them. So we usually don't have nearly as much troubles with doing through-hole parts. But the surface mount parts are smaller, the tolerances are higher, and so we really do want to get the right footprints. Okay, so that's kind of my presentation on this. We're going to pause.